Welcome back to the 35th part of Debugging at Scale, where we explain that error message. I know I said I wanted to focus on the developer side rather than on the ops side. Still, we need to understand issues with target containers and what ops are dealing with every day. If you're lucky enough to have a DevOps engineer on staff, then you probably don't need to know a lot of the product problems we discuss here. I think it's still worthwhile to build some basic knowledge about the problems we can run into with Kubernetes configurations, since there's a lot of overlap. The line where the roles end is blurry, and we need to venture into each other's realms to understand some issues. Typically, we would see most configuration issues in the status column when issuing kubectl get pods command. Here are some common errors you might run into and brief explanations on how you can resolve them. This is a general purpose issue with several causes. You will need to get further details by using kubectl describe pod and inspecting the output. A common failure is insufficient resources, which might mean you need to scale up the cluster to fit additional nodes. Volume mounting can fail if the storage is defined incorrectly for the pod. Errors that mention the word image, such as error image pull or image pull back off, typically mean a container fetch failed. One container in the configuration file can't be fetched. Check that Docker pull works with the image name to make sure we typed it correctly and that there aren't any invalid characters somewhere. Some failures in Docker pull can occur because of problematic credentials, secrets, or authorization. This often means there was a physical issue with a node host. You can see this issue by invoking the kubectl get nodes command and inspecting the nodes. A reboot of the problematic machine or VM might solve the issue in some cases, and Kubernetes should self-heal within 5 minutes. We get this error due to missing configuration keys or secrets. Kubernetes supports a config map, which lets us define values such as a database host. A secret is an API key or similar value which we don't want to place in version control or expose. It's important to separate that information outside of the YAML or infrastructure as code files so we can change it later and for security purposes in the case of secrets. The problem is that because of that separation, we can end up with missing information, since the actual configuration process requires a config map. You should use kubectl describe pod to get further information about the problem. A relatively new addition to the configuration troubleshooting process is BuildG. BuildG is an interactive debugger for Docker configuration that lets us run a configuration file while stepping over the stages. We can set breakpoints like we can with any debugger. You can check out the installation instructions in the GitHub page you see here. It integrates nicely with VS Code and other IDEs through the Debug Adapter Protocol, DAP. While stepping over the configuration, we can inspect the state of the container to see the impact of the previous line. This is a very new tool, so I don't have personal experience with it, but it looks very promising. The problems we face when debugging Kubernetes are the same ones we face when debugging most large-scale systems. The success of Kubernetes is both a blessing and a curse. It made scaling remarkably easy, and as a result, we scale a lot faster than we used to. We run into scale-related problems earlier when we might not be prepared for them and might not have the infrastructure to deal with such complexities. In the next video, we will venture into the world of serverless. If you have any questions, please use the Slack channel to ask them. Thank you.